Okay, so here is the calculator part to your Unit 1 test review. Simplify and leave your answer as a positive exponent. Well, I remember that any number to the 0 power is 1, and I also remember power to a power means I need to multiply. So this is going to be 7 15 times 6. Well, I already did the non-calculator part, so I can put 15 times 6 in my calculator and get 90. And 90 times 1, 7 to the 90th times 1 is just going to be 7 to the 90th. Let me just double check I did that right. Yes, okay. Always double check. It's a good practice. Okay, so it says Sarah works in the clubhouse store at a golf course. She receives a case containing 1,331 golf balls. The number of boxes in the case is equal to the number of packs in each box. And the number of packs in each box is equal to the number of golf balls in each pack. So I've got boxes. Well, first I have a case. Then inside I have boxes. And then in each box I've got golf balls. Okay. So I need to know how many golf balls are in each pack. All right. So if I've got 1,331, I did that last time, golf balls in this whole thing, I want you to see that if it's a case, it's going to be volume. So basically what I'm saying is that the volume is 1,301 golf balls. Now if I have a volume and I just need to know one little part of it, right? One little pack. The easiest way to do this is to take the cube root. It's because volume equals edge cubed. One edge is going to give me the equivalent of the golf balls in there. So, my calculator, I'm going to hit 3 because that's the index I want. Second, caret to get the little X guide. My calculator puts the index where it goes. Yours does not, probably if you have the 30, but it's okay. It still works the same. And then I'm going to put in the number that I want, and it gives me a perfect cube of 11. So if I do the cube root, that equals 11 golf balls per pack. Now, that wasn't as obvious as some of the other volume questions that we've had, and I apologize for that, but there is one like this on your test. Okay, so that's why we're doing this review in the first place. Which of the following is the most accurate rational approximation for the value of square root 53? Okay, so we don't have a multiple choice. So which of the following is the most accurate is probably not what this should be saying on the review, but probably what's going to say on the test. So I want you to replace that with find an accurate rational approximation. So let's see if we can put that in our calculator. Square root 53 gives me 7.28. And so hopefully there's some choice. It's either 7.3, 7.28. And if it's a whole number, I would round to 7 instead of 8. So I would pick 7 if it was only whole numbers. All right, number 15. Corey wants to install a semicircular counter in his backyard patio and needs to determine how much of the patio's area it will take up. He uses geometry to determine that the counter will take up 5 pi over 3 feet squared. If the total patio is 17 feet, so here's 17 feet squared, and I've got this semicircle. That's not a very good semicircle, but anyway, that's 5 pi over 3 feet squared. I need to know how much is left over. So this is really just a simple subtraction problem, but how you put it in your calculator is pretty crucial. This needs to be parentheses. And the reason for that is we want to make sure it multiplies and then divides. And if we don't, and then goes ahead and takes the difference. Or you can just make this a decimal, round it out to several digits. You want to round at least 3 or 4 decimal places here before you subtract it on your own. So let me show you what I mean. what I would do is push the whole thing in using these parentheses here. And I would put 5, and then I have a pi button, divided by 3. Okay, and that's what I get as the entire thing, rounded to 2 decimal places. Now, what if I didn't do that? What if I just put 5 pi divided by 3, and then went ahead and put that in separately, did 17 minus 5.2359. I get exactly the same answer. As long as I go out enough digits here, I'll get the same answer regardless, especially if I put it in the right way. So it's a good check, because sometimes your calculator didn't know what you really meant to push, right? It only knows what you actually push. Okay, 16. A contractor is installing support beams for some shelving units and needs to find rational approximations for each of the following. Plot each approximation on a number line. So, going to have a number line here. Not going to have any negatives, so what I need to do here is find the decimal equivalents, so I know where to plot them. So square root of 6 is 2.5. The square root of 11, 3.3. The square root of 19. Isn't this nice on our calculators? We didn't have to figure this all out by ourselves. Oops. Square root of 23. Okay, and I rounded to the nearest tenths place. Now I can plot my points. So 2.5 is going to be the square root of 6. 3.3 is going to be the square root of 11. 4.4, square root 19. And then 4.8, I'm going to draw it down here, is square root 23. Okay, so they're kind of squished together. I probably should have spread out my numbers just a tad better than that, but hopefully you understand what's happening. Okay, number 17 says Carly just finished hosting a birthday party and determined that her guests ate 0.73 repeating of a cake, which the following could be rational representation of the cake that was left over. So again, which of the following? So how about find a rational representation of part of the cake that was left over? So if I had 100% of the cake, I mean, you can do this a couple different ways, but if I have 100% of the cake and I subtract off 73.73% of the cake, how much is left? That's one way of doing it. I change this decimal, repeating decimal, to a percentage. You could also just leave it as a decimal. A whole would be 1. I have 1 cake, and I subtract off this repeating decimal in my calculator, and I would get the decimal version. Okay, so rational representation could also mean that it's a fraction. So remember, I need to know, how do I put a repeating decimal in the form of a fraction? Whew, we hated doing this when we first learned how. So I'm gonna go ahead and show you. Let me go ahead and find my answers to these other 2 problems that I started. Okay, so this is percent. And this would be decimal. We're going to say 2.6 repeating. Okay, so if I do this with x equals, set it equal to the repeating decimal. However many places, I'm going to multiply that by power of 10. So 2 places are repeating, so that becomes 10 to the 2nd power, which is 100. So I'm going to multiply 100 times both sides. I did not leave myself enough room. Let's try again. I'm going to do it over here to the side. X equals 0.73 repeating, and we said 100 on both sides. So if I multiply that 100, that's what I get. Now I'm going to subtract one from the other. So this gives me 99x. and that gives me 73. So then I get x equals 73 divided by 99. Remember, we divide both sides by the number in front of x. Now, what the trick is here is I need to simplify it. Okay? And first I'm going to check that 73 divided by 99 is indeed the right answer, but it is not simplified. So I got to see, does 3 go into 73? No. Does 9 go into 73? I already know that it doesn't. Maybe that is as small as it gets. I'm pretty sure that we are good to go. So I'm going to say that's my final answer for now for that one. Yeah, I'm going to go with that. I feel like I'm going to check on my calculator. I do know some button pushes that will do this for me. So nice. Yep, there's nothing. This is as small as it gets. So final answer. Okay, give examples of rational and irrational numbers as fractions. Well, first of all, irrational numbers can never ever be a fraction, so that's pretty tricky. But rational can be fractions. So let's see. If I say rationals, there's a rational. There's a rational, right? It's infinitely many right answers here. But if I'm going to have an irrational and it's in the form of a fraction, it's going to have pi in it. Pi, right? Because it's an irrational number. Or it's going to have maybe square root of some number that's not a perfect square as a fraction. Okay, these are still fractions, but they have an irrational part. So again, infinitely many right answers. These are just mine. Okay, so you'll need to come up with your own in order to study properly. Okay, 2 more. A historian estimates that during a certain year, the population of the United States was 2 times 10 to the 11th power, and the population of the United Kingdom was 8 times 10 to the 9th. By what factor is the population greater between the two countries? Okay, so we need to know how much more the United States is bigger than the United Kingdom. So this is our crazy subtraction problem using scientific notation, which means I need to have these exponents be the same. So you're going to have to choose which one do you want to change first. I'm going to go ahead and leave it in, let's leave it the 11th power. So I rewrite it. That's the first step. Now, this is going to be 10 to the 11th. And if I made this bigger by 2, I need to make this smaller by 2, which gives me 0.08. Okay, so now I can go ahead and subtract. What is 2 minus 0.08 is 1.92 times 10 to the 11th. And look, I got scientific notation. So this would be the population. This is people. Now, let's say you chose the other one. Doesn't matter? No, it doesn't matter. Let me show you. Let's say you kept this one. And you decided that you were going to make this 10 to the 9th. Okay, so you made this decrease, right, on this side. I'm sorry, so this side needs to increase by 2. So this would be 200 times 10 to the 9th. So if I do 200 minus 8, that's 192 times 10 to the 9th. Well, this is not scientific notation. The decimal's there. So in order to make this a smaller number, I need to make the other side a bigger number by the same amount, and I get the same answer. Okay, last but not least, I have number 20. Jasmine, Ron, and Shyla work together in a bakery that is known for its specialty cakes. In 1 year, Jasmine sells 5 times 10 to the squared cakes. Ron sells 7.3 times 2 cakes, and Sheila sells 1.3 times 10 to the third cakes. For a tax audit, the owner of the bakery needs to determine the total number of cakes sold in the last 2 years. What is the correct amount? So we need to add all of these scientific notations together in order to know what the total amount for the year is. So we can only add 2 at a time, and these 2 are already set up with the same exponent on 10. So we're going to just add our digits, and that'll be an exponent of 2. So 7.3 plus 5 gives us 12.3. And now we're going to bring down our other one here that we didn't add on. And again, we're in the same situation as we were in problem 19, to where we need to decide which one we're going to keep and which one we're going to change. So let's just keep the first one because it's the first one. And we can't, this isn't even scientific notation, so we could take care of that first, but let's go ahead and change it anyways. So if this one decreased by 1, this one needs to increase by 1. So 13 plus 12.3, 25.3 times 10 to the second power. It's not scientific notation until we change it. This one decrease, this one increase. And we have how many cakes the bakery sold. All right, I will see you in class.